So, hello and welcome to a new Gaia Sky tutorial. This time around I'm gonna offer a preview to the new Gaia Sky 3.2.0 that's gonna come out hopefully next week or in a couple of weeks tops. So what I'll do is I'll just pick some of the most important features that have been added in this version and I'll go over them and demonstrate them. So basically I'll be talking about the new dataset manager that we've introduced. We removed the old method, which was consisting of the download manager and then a catalog selection window. Now all of these are merged into a single dataset manager. Then I'll talk about the procedural generation of planetary surfaces, atmospheres and cloud layers. After that, maybe I'll show or I'll showcase the variable stars datasets that we have introduced. And after that, I'll talk about some other minor things like creating shapes around objects or the choosing of the preferred distance units and some other minor issues that we've fixed. So let's have a look. Maybe we start by looking at the release notes of this new version. These are the release notes for Gaia Sky 3.2.0 release candidate 2. That's the latest version that's out. And here we can see the download manager that's been rewritten from scratch. We also have the procedural generation of planets, clouds and atmospheres. Somewhere around here we have the variable star. Yeah. Here we have variable stars. Maybe let's increase this a bit. And also some other minor things like shapes or object tracking. I didn't mention that before, but we also have a new feature which tracks objects in the focus camera so that the camera direction follows a different object than the focus object. So let's jump back to Gaia Sky and we'll start the download or the dataset manager. As you can see, the welcome window is quite different from before. Now we only have 2 buttons and the exit button. Before we had 3 buttons. As I said before, the dataset manager and the catalog selection window have been merged into one. This little guy here. Maybe you'll make my face a bit small. Okay, so as you can see now we have this new dataset manager thing. At the top there's 2 tabs, one which lists the datasets which are in the server but you don't have them installed locally and you can install them. And here we have the datasets which are in your data location or the data directory. The way you change the data directory is by clicking here at the bottom where it says data location, and then you can select any other location in your disk. For example, I'll choose this one here, and as you can see here we have 2 datasets already. We have Hipparcos and we have the base DPAC, but it's outdated. So we have version 20 and version 23 is available for download, so we could go ahead and download it. But since we're not gonna use this this data location, I'll just jump back to the other one. So let's select this, and here we have a few datasets already. So what we can do from here is we can download new datasets. For example, I'll just start the download for the EDR3 very large catalog. I'll just click here, and as you can see we have a progress bar here indicating the progress of the download. And here we have also some numbers that will help us see how it's progressing. We can always cancel the download when we cancel it. the path file will be saved to disk. This means that if we ever choose to re-download this dataset again, we'll start from this same position. So the download will be resumed. We could do that now, so we just cancel it, and now we'll start again. And as you can see, we don't start from scratch. We can also start another one. This means that we have parallel downloads. Meanwhile, we could, for example, remove datasets here. So we could remove the high resolution textures dataset, and a new dialog prompts you whether you really want to download it, remove it, sorry. So let's just click yes. Here we could enable and disable datasets. Enabling datasets means that they will get loaded once we start Gaia Sky. So wherever you want to have loaded into Gaia Sky, you should click or check these checkboxes here. Okay, so let's see here. We still have this two guys downloading. We'll re-download the high resolution textures. Here in the right pane, we have some information like type of dataset, the version in the server, the size of it, the number of objects, and then description, release notes optionally, and the files that made up this dataset. So we'll download this one. Maybe we'll cancel these other two because these are rather large and it will take a while to download them. So I'll just cancel this one and also this one. Okay, so we'll just wait until this high resolution textures dataset is has finished downloading. So it will download it, and then it will check the checksum to see that that it's consistent, and after that it will extract. So the checksum check is quite fast, and now we're extracting it, and now we already have it here again. So with that, I think that's a pretty good overview of this new dataset manager. I'll just close this, and as you can see, it says that there are some problems, and the main problem now is that we didn't select any star dataset. So it tells you that hey, you don't have stars. If you want to see stars, so you should select one of the star datasets. So I'll just go ahead and select maybe the default, the EDR3 default dataset, and then we will not select the variable stars. We'll load that in afterwards. But we need this Exonia system. This is an extrasolar system, which is made up of a few planets and a couple of stars, and we'll use this to showcase the planetary surfaces, the procedural generation of the planetary surfaces. Okay, so let's close this, and now it says that everything is fine, so we'll just start Gaia Sky. Okay, so we're in already, and now we'll just have a look at the procedural generation of surfaces and clouds and atmospheres. So to do that, what we'll do, we'll press F to bring up the search dialog, and I'll look up for Exonia, and we get some search suggestions here, and I'll just select Exonia A, which is one of the two stars that composed this binary star, and then I'll just use my mouse wheel to travel to that system. So as you can see, now we're getting closer. We already see the stars, the planets, and here are the two stars. Okay, so let's have a look. We have two stars at the center, then we have Exonia C here, D, E, and F. Where is E? Here. That's Exonia E and Exonia F here. So let's have a look at this one, C. And I think this one has a moon. Yeah. So here we have Exonia C. You can see at the bottom, maybe you missed it, there were a couple of progress bars. And these were indicating that the cloud layer and the surface were being procedurally generated. And this happens on demand. When you get close enough to a planet, you get, if the procedural generation is activated for that planet, then it will generate it on the fly in the background. So that's what it looks like. To bring up the procedural generation window, we'll right click on the object, and then we just select procedural generation here. And that brings up this dialog. So here what we could do, many things actually. So we'll start with the atmosphere. We can randomize it, and that would get us different random values for all the atmospheric scattering parameters, and then we can generate it. So let's try again with different. So you can see there's very many combinations that result in different atmospheres. You can also modify these sliders manually. So for example, if you want the light brightness to be stronger or dimmer, we could use this slider here. This is the Rayleigh index, that's the Mie scattering index, fog density, and here we have the wavelength. So changing this would change the color, so you can see, and I quite like this one, so we'll just leave it. Then we have the clouds layer. Let's make sure that the clouds are visible. Here in the type visibility, and clouds are visible, so we'll just go ahead and maybe I'll reduce this scale and this scale and increase this one, and let's see how it goes. So let's generate this, and as you can see, there's this new clouds layer. Maybe this is too low. I'll increase a bit. The method, it's fine. Frequency, I'll lower it a bit, and as you can see, we get different cloud patterns depending on the noise parameters here. So basically how it works, this module of noise, the noise module here, is the same as the one used in the surface generation, but the clouds is a bit simple because it just generates a cloud map. So we can use a seed. If we change this and generate with exactly the same parameters, the clouds will change every time. So we can add a new number and you'll see that the pattern is slightly different. Then we have a noise type and fractal type. If you want more information about this, what these do and what kind of noise each of these generates, you should look it up in the Gaia Sky documentation. Otherwise it would take me a whole new video to explain just on this two. Then we have the scales. So clouds are, or not clouds, but the noise is sampled in a 3D volume, and these scales are the dimensions of each of the coordinates in this box. So if you increase the z a lot, you will have a box which is x and y, and then z is quite large. So you will have, like here, you see that the noise size, or the size of the patterns of noise in the z direction, is much smaller than in the other two. Then we have the frequency, and this is the frequency of the octaves, the linearity. Then we have the number of octaves. This means that the noise algorithm runs more than once with a reduced frequency and a different amplitude, or an increased frequency and reduced amplitude, to generate successive noise patterns in different scales. Then we have the ranges. This is basically the mapping values for the lowest noise point and the highest one, and then the power, which is basically a power function applied afterwards, after the noise has been generated. So the power would increase high values and flatten low values. Okay, so maybe we disable the clouds because we're gonna look at the surface now. So the way the surface works is it generates essentially two maps using the noise parameters. The first map is an elevation map, so you have a 2D map. At each point there is a value which we'll interpret as elevation, so height, and then we generate also humidity map. So same thing, but each value contains a humidity value from 0, which is totally dry, to 1, which is totally saturated. Then we use this map. So these two maps, we map them in this lookup table. So we have this lookup table. There's several versions of it. Let's not here shift them. For example, this one, we would map the humidity to X. So this is less humid and this is more humid. As you can see, less humid contains yellows for desert, more humid contains greens for rainforest. And then we map the elevation to Y. So very low elevation contains blue, which is the seas. And as we go up, we go to the whites of mountaintops with snow. For each of these textures, we can hue shift them. This means changing the colors by rotating them in the HSL color scheme. And as you can see, when we apply a rotation, the colors change. This gives us quite a lot of variety. We can also use discrete textures like this one. So this doesn't contain smooth gradients, but hard edges between the colors. We could regenerate the surface with the same parameters and changing this texture, and you'll see how it changes. So I'll just go ahead and do that. You'll see that it's exactly the same height button, but the colors will change. So let's do it. So you can see here at the bottom, it's generating, and now it's finished. So this is a much more Earth-like planet, as you can see, and the colors have changed quite a lot, and there's hard edges between colors. That's the smooth version. Then we have one for browns and greens. We have a psychedelic texture, which doesn't really match anything in reality. And then we have one with grays and a 1D texture, which only uses elevation. So we'll just stick with this one. Okay, so here we have the same noise module as in the clouds, and this is the height scale that's not present in the clouds. This basically maps the highest point in the elevation texture to a real elevation. So in this case, the highest mountaintop would be at 21 kilometers. So let's randomize it and see what comes out. So this is a desert planet, basically. It doesn't have much in it. Let's try again. That's an interesting looking one. It's mostly sea though. Let's try again. That's taking a while because I guess, yeah, that's nice. That's a weird looking planet. Let's try again. Green planet. Once again. Okay. Now I'll try to create an Earth-like planet. So I'll lower the frequency a bit and I'll increase this. The octaves, I'll put them to the top, and then this will put here. That would go to 1.1, the power to 2.1, and then the Earth would be at like 9 or 8 or something like that. So I'll go ahead and try this. Oh, I missed. I forgot about the lookup table. So we'll not hue shift it, and maybe the scale would be something more like 1, 1, and 1. Frequency, I think it's fine, and that's also fine. And let's try this. So as you can see, this looks like the Earth a bit more. Maybe the algorithms that we used are not the best for creating an Earth. Maybe we'll try this and then simplex noise and try again. Yeah, that gives many more mountains than expected. Maybe the multiplier here is too large. Okay. And now we'll try with a lower frequency. Okay, that's fine. Maybe more C. And try. Maybe a bit more. I'll lower the frequency a bit, and also this. Yeah, so that's pretty good already. You could play around with it a bit more, but in the end, you're just gonna get variations of the same basic model. Okay, so now we'll use the same object to demonstrate the shapes on objects. So now we have a new feature here, which is add a new shape around whatever object you have selected. So in this case, Rechen-Institut. And this what this allows is to add different types of shapes around objects with a certain size. So for example, I'll just use 0.1 astronomical units for these. We'll use an icosphere, color maybe yellow with some transparency, and we'll use lines. This would give us wireframe. If we choose triangles, we would get a solid object or a solid model. But in this case, we just want a wireframe to mark the 0.1 astronomical units from this object. So when we create it, we see that it appears at the background, and it is actually a 0.1 radius sphere around this Rechen-Institut. So we could activate the recursive grid, and maybe we need to center it around the focus object. To do that, we go to the interface settings, and here in recursive grid origin, we select focus object. And now, as we can see, the sphere is exactly, I don't know if you can see it, but the sphere is exactly at 0.1 astronomical units. Let's make this a bit larger with the field of view. So you can see here, that's the 0.1, the red line, astronomical units mark from the focus object, and the sphere is exactly there. So, what's next? Maybe we'll go home. We're back at the Earth now, and maybe we'll load some variable stars. If we come here to the dataset manager, and you have version 2.0, you should have these variable stars. A dataset. This is where is it? Gaia Star catalogs. Here, this one. So that is available to all of the Gaia Sky 3.2.0 users. You can download it from here directly. And what we'll do now is we'll just sideload it from the interface. So we just look for it, Vari, that should be in here, and that's the catalog we want. So we'll just say load catalog, and here at the bottom there's a new option which says variable stars with light curves. We will scale the magnitudes, that's just an additive factor. So let's see exactly what this does. So additive scaling factor to apply to the apparent magnitude. So apparent magnitude is the current magnitude minus this factor. So we'll scale it like 8 or 9 magnitudes so that the stars get really bright, and we'll just load them in. Did it load? Is it loading? Oh yeah, it did load. So yeah, we have now variable stars and also the default EDR3 dataset. So I'll just go ahead and mute that one so that we only see the variable stars, and these are the variable stars in Gaia Sky. We could here we have it at the bottom, and we could highlight them, and as you can see, all of these stars are pink or purple, and these are the stars in this catalog. So how do we make them actually pulsate? So the way to do that is just start time, and then I'll increase time. What I did is press spacebar. When you press spacebar, you start and stop the time, as you can see here at the top. And then I'll use comma and dot or period to decrease and increase the time speed. As you can see, now we are at 128 times faster than real, and we'll just keep doing that until we see some variation. And as you can see already, oops, I just left the solar system. So this is the Earth. Maybe let's have a look at one of these. Maybe we'll move towards these. This is the Earth cloud. And now we will get closer to this, some of these variable stars. But we can already see them quite nicely. So maybe we just need to adjust the star brightness to make them a bit larger. And as you can see, they are actually pulsating, or they are variable. You see this one is quite fast in its period, some of them not so much. But this would be the new variable stars data set. Here you see clearly that they blink. Okay, so stop time. Finally, some minor things. For example, we added, let's go back to the Earth. We added the distance from the camera to the sun here at the bottom. This was missing. We only had the distance from the focus object to the sun, but not from the camera to the sun. That may be useful in some situations. Also, we have some extra settings. For example, here we have these the preferred distance units. We can select now light years or parsecs. By default, parsec is enabled, but if we change it to light years, you will see that here now we are quite close to the solar system, but if we save this and we move out, you will see that distance units top at light years. We can change it back to parsecs, and you see now it's parsecs. So I think that's pretty much it for today. I hope I didn't miss any important features for this version. Otherwise, I'll just make a follow-up video to explain those. So thanks for watching, and I'll see you in the next video. Bye bye.